शायद कॉलेज वाले से जुड़ गए। अब बोलना चालू करिए सर रिकॉर्डिंग। मैं स्क्रीन शेयर करता हूँ।
माउस यूज करना चाहिए सर।
Hello students. Hello.
Good morning, sir.
Good morning to all of you. Good morning to all of you.
Good morning, sir.
Okay. Today we discuss about the destructive distillation of coal tar and isolations of compounds. Okay. First we discuss about the destructive distillation of coal tar.
देखो ना सर पढ़ा रहे बोल रहे अभी शुरुआत हुई।
Please listen me. Destructive distillation of coal tar. Okay. What is the meaning of destructive? Destructive means to break down, to break into the different components. Distillation means separations. We can separate or purify the compounds, and of which compounds we do the destructive distillation, that is a coal tar. Okay. So destructive distillation of coal means we break down the component of coal. Okay. We break down the component of coal into different fragments. Distillation means action of purifying the liquid by distillation process, by heating and cooling of the compounds by which we separate it. And coal is a compound in which there are so many components. This is the mixture of hydrocarbons, and when we do the destructive distillations, it break into the different components. Destructive distillation, definition of destructive distillation is we heat the coal powder at high temperature, about 100 degrees, 1000 degrees centigrades. Okay. In absence of air or oxygen in the heat resistance test tube, that is known as retort. Okay. When we heat the coal powder at high temperature, it breaks down into the following components. And you see the figure. This is the figure. You can see this figure. There is a test tube. That test tube is heat resistant. And in that test tube, we take the coal powder. Okay. And this test tube is connected with the another test tube in which water is present, and there is another tube which is coming out from the second tubes. Okay. And you can observe these figures, destructive distillation of coal tar figures. And this coal, when heated at high temperature, that is 1000 degrees centigrades, what happens? In absence of air, it converts into their components. Okay. And it passes through the tubes and enter into the liquor of the another tube, that is the water. And the gas is absorbed in the liquors, that is ammonia, and from the ammonia liquors, and another coal gas, volatiles, it come out through the another tubes and it is known as coal gas. Okay, and at the bottom, coal tar, that is a viscous liquid, is sedimented at the bottom of the tubes. These are the four products, that is coke after burning of the coal, but remain present in the test tube first, and volatile gas, that is coal gas, is coming out from the tubes, and liquor ammonia, which is absorbed in the liquid, and coal tar, which is sedimented in the bottom of the tubes. And you see the different compounds, that is a coal tar, which is a black viscous thick liquid. It is mixture of about 200 substance, that is a hydrocarbons, and it is used for preparation of manufacturing of many substance. Examples: perfumes, cosmetics, shampoo, anti-dandruff shampoo, lice repelling shampoo, medicine, plastic, paints, dyes, artificial fibers, for example polyester and nylons, pesticides, naphthalene balls, medicines, and road surfacing materials. And second is ammonia liquor. This is the colorless ammonia gas layer formed just above the coal tar. Ammonia gas, after reaction with water, form ammonium hydroxides, that is ammonia liquor. And when it is treated with the sulfuric acids, form ammonium sulfate, used as a fertilizer to grow the plants. You can see the reactions. Ammonia, when react with the water, it forms the ammonium hydroxides, and these ammonium hydroxides react with the sulfuric acids, form ammonium sulfate, which is used as a fertilizer. And third one is coal gas. Unreacted gas release out mixture of, and it is mixture of methane, hydrogen, and carbon monoxides, having the unpleasant smell. It is used as a fuel in the industries. Fourth one is coke. Residual substance remain present in the first test tube. It is a porous black brown color having 80% carbon, and it is used as smokeless fuel. It is used as also reducing agent to convert the metal oxide into the metal. For example, zinc oxide, this is the ore of zinc, and when it is treated with the coke, that is the carbon, during the metallurgical process, it reduced and zinc is separated and carbon monoxide is formed, so that we can use the separation of metals from the metal oxides with the help of coke. Second utility is, it is used for preparation of steel. It is a mixture of carbon and coke, carbon and irons, that is a alloy. Fifth one is gaseous component from coke. It is used for production of water gas. Coke, that is a C, when treated with the steam, that is a water vapor, it forms the carbon monoxide and hydrogen, and it is combinedly known as water gas. And this water gas is used for production of producer gas. Water gas is used as a industrial fuels. And second thing is, coke is also used for production of producer gas. Coke, when treated with the oxygen and nitrogen, that is air, it forms the carbon monoxide and nitrogen, and combinedly it is known as producer gas. Both are water gas and producer gas, both are used as a industrial fuel. And now we come about the isolation of products. What is the meaning of isolations? Isolation means separation. Okay. Products are isolated or separated by coal tar distillation process or by the process of fraction distillation, which is carried out in the petroleum, that is a crude oil, in case of crude oil. Fraction distillation of coal tars, you can see the different fractions. It is, we can obtain the different fractions, that is a light oils, middle oil, heavy oil, anthracene oils, and last one is pitch. These are the different fractions obtained after the fractional distillations of coal tar or after the destructive distillation of coal tar. Okay, and there is a temperature range in which it is found. Temperature light oil, in case of light oil, it is up to 200 degrees centigrade, and specific gravity is 0.9 to 1. And chief component which is present in the light oil are benzene, toluene, xylene. In the middle oil, temperature range is 200 to 250 degrees centigrade, and specific gravity is 1 to 1.02, and it is dominantly found naphthalene and phenols. Heavy oil, temperature range is 250 to 300 degrees centigrades, and specific gravity is 1.02 to 1.1. And in the heavy oil, cresol is mainly found. Next one is anthracene oil, and temperature range is 3 to 350 degrees centigrade, that is 1.1 to 1.2, and anthracene is present in the anthracene oil. And last one is pitch, that is a remain present as a residue. Okay, and you can see these are the fraction of different fraction of coal tar distillations. And these, what is the meaning of fractions? Coal tar is divided into different fractions at the various temperature, at different temperature. For example, in case of light oil, 200 degrees centigrade is required, and we get the light oil fractions. And in that light oil, benzene, toluene, xylene is present mainly. Okay. In case of middle oil fractions, the range of temperature in which it is obtained 200 to 250 degrees centigrades. And in this range, naphthalene is present. So that we get the different fractions by the destructive distillation of coal tar, either by the fraction or isolation of crude oils. In case of crude oils, we heat the crude oil at high temperature, that is 400 degrees centigrades. You can see the pictures of refineries, simple figure of the refineries. You see the simple figures. Crude oils, when heated at high temperature, and that process is known as cracking. And by the cracking process, it converted into different fractions. So that this process is known as fractional distillation of coal tar. Okay, and you can see the figures. This is the refineries figures. This is the feeding of crude oils through the this furnace. This is the furnace, and in the furnace we heat the through the furnace we heat it at 400 degrees centigrades, and crude oil come into the bottoms, and it come in contact with the 400 degrees centigrade temperatures. And what happens when it get temperature? Volatile gas is evolves, and it come to the highest top of the refineries, and this is the almost room temperature, that is at 20 to 25 degrees centigrades, and this gas is collected, and carbon atom, this gas consists of C1 to C4, and this is a natural gas, and which is used as a LPG, CNG, okay, as a fuel gas. So that you can see the another fragments or fractions, that is a C5 to C11s, that is a petroleum ethers obtained at 30 to 80 degrees centigrades. And there is a second components, we obtained the 90 to 170 degrees centigrade, that is gasoline. Actually this is the petrol. Okay, we can get the different fractions at different temperature. And just below gasolines there is a kerosene, and temperature collection temperature is 170 to 250 degrees centigrades, and it is used as also it is used in stoves and others uses. Diesels 250 to 290 degrees centigrades, it is used in the diesel motors. Heavy fuels was, and it is consist of it is also used in the sea as a fuels. And remaining you can see the residues in which this what you can see at 350 to 400 degrees centigrades, that is a paraffin wax, coke, and residues as a bitumen, and lubricating, it is used as a lubricating agents. Paraffin wax used in the ointment, candles, and toilets, vaselines, and for the manufacture of wax papers. And this bitumen, that is a pitch, which is, this is the non-volatile residue solids, and it is used in the manufacturing of roads surface. डामर की रोड जो बनती है ना, ये बिटुमिन से बनती है. Okay. You see the explanation of different fractions, that is light oils beside benzenes, toluene, xylenes. Light oil consists of these ones, and having the small amount of acidic substance, that is phenol and cresols, and basic substance as pyridine. It is treated with the sulfuric acids at low temperature to remove the bases. Then it is neutralized with caustic soda, which removes the phenols and excess acid. The oil thus purified on redistillations yield benzene at boiling point 80 degrees centigrades, toluene 110 degrees centigrades, and xylene having the boiling point 135 to 145 degrees centigrade, so that we can get the different fractions at different boiling point temperatures. And light oil, when treated with the H2SO4, cold H2SO4, concentrated H2SO4, bases are removed, and then it is treated with the alkali, phenols are removed. And after distillations, we can get benzene, toluene, and xylene at different temperatures or different fractions due to different boiling temperatures. Second one is middle oil, having that range of temperature is 200 to 250. It contains the naphthalene, phenol, and cresols. Naphthalene settle out upon the cooling, is separated by centrifuging by the centrifugal force and purified by sublimations. After removal of naphthalene, phenol, cresols are removed from the remaining oil by treating with the sodium hydroxide solution and then saturating with the carbon dioxide. The mixture of phenol so liberated is fractionally distilled to yield the phenols at boiling point 183 degrees centigrade. And mixture of isomeric cresols, that is a boiling point 191 to 201 degrees centigrade. Middle oil, we get the by the destructive distillation and centrifusion, then we get the naphthalenes, and remaining oils, which is treated with the caustic soda and carbon dioxide and get the phenol and cresols. Heavy oil, and it is obtained in the 250 to 300 degrees centigrade range. Main component of these fractions are naphthalene and cresols. It is used as in the preservatives of timbers under the same creosote oil. Anthracene oil, and it is found in 300 to 350 degrees centigrade. This fraction on cooling form crystal of anthracene, which removed by filtrations. These are washed with the solvent to remove the phenanthrene and carbazole also present in the anthracene. The remaining solid is sublimed to get pure anthracene. Last one is pitch. This pitch is residue used for waterproofing purpose, waterproofing of roof and roads, manufacturing of road surface. And you can see that we can get the different products like the benzene, toluene, and xylene. This is the how we can prepare the benzene, xylene, and toluenes from the petroleum products, because coal tar distillation is stopped after 1940, and now these days we get these solvent benzene, toluene, xylenes are obtained from the petroleum, that is a crude oils. Okay. हाँ अटेंडेंस आप लोग भेज देना कमेंट सेक्शन में, अटेंडेंस भेज देना. You see these the hexanes. Hexanes, when treated with the catalyst, that is a platinum aluminum oxides at high temperature, that is 500 degrees centigrade, it converted into the benzenes, and this the 4s2 is separated and we get the benzenes. Like by the catalytic by the catalytic distillations, we do the cracking. This is a cracking process known as cracking process. Means a breaking of higher hydrocarbon into the lower ones. This is the cracking process. And heptanes is treated at high temperature, that is 500 degrees centigrade, in presence of catalyst, that is a platinum and aluminum oxides, form the toluene. And third one is octane, and it similarly it gives the xylene and ethylene benzenes, and hence we get the benzene, toluene or xylene from the crude oils. Benzene is recovered from the mixture by the solvent extraction and fractional distillations. Toluene is the major product which is converted into benzene. This is done by passing the toluene with hydrogen over platinum and aluminum oxides as a catalyst at 500 degrees centigrade, and we get the benzene. You can see the reactions. And 90% benzene is derived from the petroleums, and benzene, toluene and xylene are basic raw materials which are used for manufacturing of most of the aromatic compounds. And this benzene, these are the basic components. And for the manufacturing of medicine, for the manufacturing of dyes, we make the intermediate products from the basic raw materials, and that intermediate products are used as a raw material for pharmaceutical industries, for dyestuff industries, for the paint industries. Okay, and you can see in the figures, this is the benzene. By the benzene we get the phenols, we get nitrobenzenes, anilines, sulfonylic acids, toluene, benzene sulfonic acids. These are the known as intermediates which are used for manufacturing of different substances. Okay, students, thank you.
अटेंडेंस में एक बार और बोल दीजिए।
अटेंडेंस किसी का बच गया हो तो आप भेज देना।
Okay, sir.
ओके।